Hi Jess, this is your feedback from the topic test in class in Spesh. Some good work in here. There's also some gaps, but it was also a long test and probably not that well written. Okay, so to the first question you got 0. And you got 0 because you've drawn a circle and it's not a circle. So I would agree with here, you've got an expression for t. You know y equals 3t, so take this expression that you have for t and replace the t. So you know with y equals 3 lots of what you have over here, which is minus a half x minus 3. So minus 3 on 2, x minus 3, which is minus 3 on 2x plus 9 on 2. A straight line that goes through at 9 on 2 and at 3. Now, the range of x of t will be the range of this. And the range of this as t is 0 would be 3. And then as t gets bigger and bigger and bigger, this gets minus. So we're going to go from minus infinity to 3. So that ends up being the domain, the range of x of t. And the range of y of t, well, that's going to be 3t, and t goes from 0 to infinity, so that's going to be 0 to infinity. Which means what we're drawing is this line here. So the minute you didn't get the equation, then you're in a bit of trouble with the circle, etc. You've said the starting location is 5, 0. But even if I come up here and put t 0, I'm at 3 and 0. So I've got to start at 3 and 0. So to find that starting location, make t equals 0 right up in this parametric equation. Okay, question number 2 was 2. You gave me 2 answers, but you were told in the question that t is positive or 0. So therefore, I'm only looking for the positive. So that was well done. Question number 3, you got 4 correct. Correct. You got up to here, but the numbers became a bit awful. You just needed to find C. So you made no mistakes in what you were doing in this question. Question number 4, you didn't attempt. Question number 5, you got 9 out of 10, which is really good. Great graphs. I just don't think there's ever any constant velocity. Constant velocity looks like this. And our velocity graph, which is this one, at never any stage does it have a constant. It's always changing. There's a t in there, and that's always going to change. So I think there'd be a never for that particular question. Question number 6, 6 out of 7, which is really good. I don't think you read this or you didn't have it in your bound book. To convert meters per second to kilometers per hour, you multiply by 3.6. The distance, I should have taken an extra mark off, but anyway, this is the 30th second. So between 30 and 31, I'm looking for the area, and that will be 24 times 1. It should be 24 meters. That's how far it travels during the 30th second. Because we are traveling at constant velocity of 24 between 10 and 70. That means we are traveling 24 meters every second. So in the 30th second, it's 24 meters. And you've got a correct area. So that's really good. Question number 10, question number 7, you didn't attempt. And question number 8, you didn't really attempt, except you did pick up a mark here for stating the derivative, and you picked up a mark for giving me the times that the minimum and maximum speeds occurred. So that was good. Areas to work on, you can see where the gaps are, and you can have a little look at my solutions as well. But overall, well done.